Hello everybody, today we're going to go ahead and start on day 3 notes. Day 3 of Unit 1. We're going into simplifying algebraic expressions, specifically using combining like terms. That's what the CLT means. I just lost my train of thought. Sorry. So today, is it the first day? It's not the first day. I thought it was the first day you saw variables, and I'm like, no, it's not. You've seen stuff already when you did evaluating, right? But now you're going to see variables where you can't get rid of them. So you're going to have to deal with them, and I'll show you how to deal with them. So let's go ahead and get started. So we're talking about simplifying algebraic expressions. When we simplify them, okay, simplify, not evaluate. Evaluate is when you can sub a number for a variable. Simplify means, like we did with order of operations, is to try to get it down to a single variable. Now, because we have not a single variable, a single number. Because we have variables in it, we're not going to be able to get that single number. So when we say simplify for algebraic expressions, what we're meaning is trying to do as many operations as we can. We know we're not going to be able to do all of them. We can try to get rid of some of them. Okay? And there's two ways we can do it. We can combine like terms, and we can use the distributive property. Now, we're going to talk specifically about combining like terms, where next class we'll do distributive property. Okay? So let's go ahead and get to combining like terms. In order to do that, we need to know what terms are. So terms are part of an expression that are separated by an addition sign. Okay? So if you see an addition sign in between two parts of the expression, you have two different variables. If you see a subtraction sign, it's almost the same thing. Subtraction is the same thing as adding a negative. So if you see a subtraction sign, there still are two variables there. It just means that you're going to be adding something with the negative of that second term. Okay? So let's look at some examples. So here, we don't have any addition sign. It's all being multiplied together, negative 4x and y. Because we're not separating it with an addition sign, that's all one single term, even though there's three different components to it. It's one term. Okay? Here we have an x squared and the 16, and it's separated by a subtraction sign. We could go, I'm going to show you how to do this. We could rewrite it to say x squared plus negative 16. That means the exact same thing as this right here. Okay? So x squared is one of our terms, but negative 16 is what's separated with the addition sign. So that minus 16, just think of it like a negative, and just keep that minus sign with the number behind it. That's our other term. So altogether we have two different terms. Okay? Over here we have this term, the negative 4y, even though it's being multiplied, it's one term. Separated with the addition sign with the 6x, so that's another term. And then the minus xy, we could think of it as plus the negative xy. So negative xy, the whole thing with the minus sign, is our third term. So we have 3 total. Okay? So you guys are going to try this on your own and see how many terms you can get for each one. It might be beneficial for you to not only write how many terms, sorry if you hear things in the background, sorry, it's just asking how many terms, but it might be beneficial for you guys to write out what those terms are to make sure you can identify the terms as well as figure out how many there are. Okay? So give that a try on your own. Like terms. So now that we know what terms are, we can figure out what like terms are. Like terms are terms that have the same variable, okay? So same letter, and that letter has the same exponent, okay? So same letter and same exponent. Those are like terms. Some examples of like terms would be 3x and negative 5x, because they both have the same variable of x and they don't have an exponent. So these are like terms. 5x and x, they both have that single x with no exponent. So 5x, even though it has a different number here, in the front, that's okay. This one has that invisible, it has an invisible 1 in front of it. So if I had to put a number here, I could put a 1. This one has a 5. That's okay that they have different numbers in the front. It's the number that hangs off the back that needs to be the same, the exponent. Okay, 6y squared and negative 12y squared, they both have the y squared part. So that's what makes these like terms. And finally, 9 and 13 are like terms. Okay, the reason we can combine those are because they are like terms. They're alike because they don't have a variable. So they have the same variable of nothing. Okay, that's why we can go ahead and combine them. And just so you're aware, combining means add them together. So that's what we'll be doing when we talk about combining like terms. But before that, we need to know what like terms are. And we need to make sure we know what non-like terms are so we don't combine them. If they're not like, we can't combine them. So here's an example. 3x and 3 are not like terms because they do not have the same variable. This has an x, this has no variable. They're not the same. Okay? 7y and y squared are not like terms. Yes, they are the same variable. They both have y's, but this one doesn't have an exponent, and this one has an exponent of 2. They are not the same because they do not look identical. The variable part does not look identical to it. Okay? And then 2x, or negative 2x and negative 2y are not the same. Not only do we not have the same letter, okay? Really, that's the only reason. They're not the same letter. They do have the same exponent of nothing. And they have the same coefficient, which is the number in the front, but they're not the same letter. So these are examples of non-like terms. These cannot be combined. Okay? So now I gave you a hefty challenge. Okay? I want you to go through this box and try to put all of these numbers in the correct circle. So I want you to group the circles with like terms. Okay? Some of these are a little bit more difficult because they all, like a good portion of them have A and B, and even more of them all have A's. But just because they have some of the stuff that looks identical, in order for them to be like terms, the entire variable part has to be identical. So all the variables in that term and the exponents for those variables have to be identical. So go ahead and try that one on your own. You can pause the video or come back to it at the end. Alright, now that we know what like terms are, how do we combine them? I kind of already gave you a sneak preview. In order to combine them, we're going to just add the coefficients of the like terms. So the number in front of the variable, we add those numbers together, and we leave the variable and the exponent alone. So 3x and 5x, 3 plus 5 gives us 8, so our answer, when we combine it, would be 8x. We keep the x part, the variable part, the same, and we just change the number in the front. Okay, so here are a couple examples. We're going to simplify it by combining like terms. So we have 2a plus 3a minus 8b. Okay, well 2a and 3a have the same variable and exponent, but negative 8b is not the same because it's a different letter. Okay, so we can combine these two. To combine it, I just add 2 plus 3, gives me 5, and keep the variable they have in common. So that becomes 5a. The negative 8b, just bring it down, and it tacks on with the 5a. And that's my answer. Okay? I did some operations. I did the addition, but that's as far as I can go because I don't know what these variables are, so I can't combine them and I can't simplify them. So simplifying, you might not be able to get to a single value, but we're going to do the best we can. Okay? B, I got 5n plus n minus 3n cubed. So just so you're aware, this n and this 5n, they're the same variable and the same exponent and everything, so they're like terms. When I combine them, okay, I've got the 5 here for this n, that's the coefficient for this one. This n doesn't have a number. If you don't see a number in the front, it's because it's invisible. Okay? If there's no number there, you can automatically assume that the coefficient is 1. Okay? So that's what I'll be adding together. The 5 here and the invisible 1 for this coefficient. 5 plus 1 just gives me 6. they have the n in common. I have the n there. And then this guy doesn't have any like terms, so I can't combine it with anything, so I just bring it down. And that's my answer. Okay? And then C, I've got 6x squared plus 9x plus y squared minus 9x plus 4y squared. Well, the 6x squared, there's no other x squared. There's only x's, so I can't combine it with anything. Now this 9x, I can combine with this negative 9x. Remember, I'm trying to keep the sign in front of it. Okay? I can combine those two, so I can do 9 plus negative 9 to get my new coefficient. And then this y squared and this negative 4y squared have the same variable of y squared. So I can combine these. This doesn't have a coefficient in the front. So what I can do is I can make it visible. It's just the 1 again. And make that visible so I have something to combine with. So the 9x and the negative 9x combine, and the 1y squared and the negative 4y squared combine. I add those together. The 6x squared just gets brought down. So I have 6x squared plus 0x, because that 9's actually canceled out with each other, creating 0, minus 3y squared. Now, I could simplify this further because I know that 0x is 0, and I don't have to write the 0. So I could simplify it even further, just saying 6x squared minus 3y squared. And that would be my final answer. Okay? So now you guys are going to try these two on your own, and that's it for the video. If you have any questions, please write them down, and then we'll go over them in class. Okay? Alrighty. I will see you guys next class. Bye!